solving linear equations. The letters in algebra are called variables because they vary from problem to problem. The numerals are called constants because they remain the same from problem to problem. Okay, we've already stated that once before. Now, be very careful about the difference between an expression and an equation. Expressions do not have equal signs. You cannot solve an expression. You can only simplify or evaluate an expression. Now, equations, on the other hand, they do have an equal sign. Notice the word equate, equal. It's part of the word. You can solve an equation. In other words, you can find out the value of the variable for that specific instance. An equation where your only variable, now we're saying A's, B's, C's are usually numerals in the problem, but the variables, X's, Y's, and Z's, doesn't have an exponent on it, right? And you just have one. We call that a linear equation in one variable. If you can make two or more equations that have the same solution, they're called equivalent equations, just like equivalent fractions. 1/2 and 2/4 is the same value. So x plus 2 equals 3 and x equals 1 are equivalent equations. X is 1 in both of these. 1 plus 2 is 3, x is 1. Right? Equivalent equations. So to determine if a number is actually a solution to an equation, then you plug that number into the equation and simplify both sides. If both sides are equal, the number is a solution. Okay, so is 5 a solution to this equation? Well, let's plug 5 in everywhere there's an x and just see if both sides wind up being the exact same thing. I just changed that to a 5 and that to a 5. Everything else stayed the same. So 3 times 5 is 15. Now I'm just going to do my math on each side. 5 plus 3 is 8. Oh yeah, 15 minus 7 is 8. Yes. Yes. Is 1/2 a solution to this equation? I don't know. Let's plug it in and see. And if I'm working with fractions, I want everything to be a fraction. Right? So these that are not fractions, put them in their fraction form by putting them over 1. Now here I'm multiplying two fractions. Nothing will simplify, so multiply straight across. Here I'm adding fractions, so I need a common denominator. So that makes that 26 over 2 plus 1 over 2. Now that they have the same denominator, this side I can't do anything else with, but now that they have the same denominator, I just add numerators. Oh, that's not equal. So no, 1/2 is not a solution to that equation. Okay, so checking to see if something is a solution. And then, well, how do you find the solution? The addition property of equality tells us that if two things are equal, we can add the exact same thing to both sides and they remain equal. In other words, look at this. If I have 1 plus 2 is the same thing as 3, as long as I add the same thing to both sides, I can add 5 over here and 5 over here. Right? Then that stays equal because really this is 3 plus 5 is 3 plus 5. Same thing for the multiplication property of equality. I can multiply both sides by the same thing. So once again, if I wanted to multiply by 5, as long as I do the same thing to both sides, this is basically saying 5 times 3, right? and 3 times 5. All right, so we're going to use those ideas to make equivalent equations step by step. Here's the steps. Okay, anytime I see an equal sign, I got to make sure I have an equal sign. Anytime I have an equal sign, the first thing I'm going to do if it has fractions is get rid of the fractions. Okay, after you get rid of the fractions, get rid of parentheses. Simplify each side of the equation. Put all your variables on the same side. Undo anything being added or subtracted. Undo anything being multiplied. You might want to make yourself a little list of these steps. And we're going to do this anytime we're solving any linear equation. Let's look. All right. Get rid of any fractions, no parentheses. Okay. Simplify each side. So look and see if there's any math you can do on each side of the equation. And right here, that's just two numbers. So signs are different means minus. 4 minus 1 is 3. Keep the sign in front of the bigger number. There's nothing on the other side to do because I can't combine variables and constants. Right? They're different kinds of things. So once everything is simplified, put all your variables on one side. I like them on the left, but it's okay for them to be on the right. So since it's already over there, it's okay. They're all on one side. Undo anything being added or subtracted to that variable. Now what that means is by undo, I'm going to do the opposite. If I have a minus 2, I'm going to do a plus 2 because I want this to be 0. I don't want there to be a number over here with my letter. Okay, whatever I do to one side to keep it balanced, to keep it equivalent, to keep it equal, I have to do the same thing to the other side. So now I have 3 plus 2 on this side, and on this side I have y plus 0. Oh, once you get your letter equals a number, you're done. Okay, I don't have fractions. I don't have parentheses. Do any math you can do on each side. Okay, so signs are different means minus. 14 minus 8 is 6 m's. Keep the sign in front of the biggest one. Signs are different. It means minus. 60 minus 6 is 54. Keep the sign in front of the biggest one. Okay, put all your m's on the same side. They already are. Undo anything being added to the variable. Nothing's being added to it, so undo whatever's being multiplied. Divide by -6 because that makes that 1. But whatever I do to one side, same thing to the other side. So over here I have 1 m and a negative divided by negative, positive 54 divided by 6, 9. Okay. I don't have parentheses, I don't have fractions, I don't have parentheses. There's no math I can do on either side. Put all your variables on the same side. Look, this time I have variables on both sides. Nope, can't have that. So I'm going to take that off of this side. In other words, I'm going to take away 3 x's from this side because I want 0 x's over here. But whatever I do to one side, I have to do the same thing to the other side. Okay, now 5 x's minus 3 x's is 2 x's equals 10. Once all your x's are on the same side, undo anything being added to that variable. Nothing's being added. So undo anything being multiplied. So I'm going to divide by 2 to make 1. But whatever I do to one side, same thing to the other. So now 1x equals 10 divided by 2, 5. Same steps every single time. Let's see it again. Okay. No fractions. Oh, but this one has parentheses. So get rid of the parentheses with our distributive property. 10 times c is 10c. 10 times -6, -60, plus 4. There's no parentheses on this side, so it's just going to stay the same. Now, anything that you can combine on each side, any math you can do that. Okay, so 10C, I don't have another C, but these are just numbers. Signs are different, means minus. 60 minus 4 is 56. Keep the sign in front of the big one. Okay, I don't have another C, so that'll stay. But these are numbers. Signs are different, means minus. 58 minus 2 is 56. Keep the sign in front of the big one. Okay, now move all of your variables to the same side. So I want this C gone from this side. So I'm going to take away C. Whatever I do to one side, same thing to the other. That means I have no Z's left over there. 10 C's minus 1 C leaves me 9 C. Minus 56 equals 0 minus 56 is minus 56. Once all your variables are on the same side, undo whatever is being added or subtracted to that variable. This time I have a minus 56, so if I undo it, I add 56 to make this 0. So I'm going to add 56 over here. Oh, hey, look, that also makes that 0. So 9C plus 0 is 9C equals 0. Now, undo whatever's being multiplied to your variable. Now, undo that by dividing so that I have 1C. Whatever I do to one side, same on the other. Okay, I got a 0 and a fraction. I got to be careful. The zero's on top, the number's on bottom. Right on. That's okay. That means it just equals 0. Can't have a 0 in the bottom. That would be no. This one's okay. Okay, no fractions, but I have parentheses again. So I'm going to get rid of these parentheses. Negative 10p minus 10 minus 7 equals, I have some parentheses on the other side, so 6p plus 15. Okay, simplify, do any math you can do on each side, and the only thing I can do is combine these constants, so that's negative 10p. Signs are the same, it means add. Keep the sign in front of the big one. 6p plus 15. Okay, when there's nothing left to do, now you start solving and moving, only now. I don't want any p's over here. So I'm going to take 6 p's away so that there will be 0 p's over here. But I have to do the same thing to both sides. Signs are the same, so add. Keep the sign in front of the big one. 0 plus 15 is 15. Okay. Undo what's being added or subtracted to your variable. So that would be minus 17 plus 17 would give me 0. Same thing over here. Negative 16p plus 0 equals 15 plus 17, 32. Okay, undo whatever's being multiplied to the p, so I'm going to divide by negative 16 so I can have just 1, positive 1. Okay, so 1p equals 32 divided by negative 16, negative 2. Okay, fractions. To get rid of fractions, find the common denominator. I only have one denominator, so that's 6. I'm going to multiply everything, every single number, all the way across, not in parentheses if you add it, but everything else by 6. Now, that means that gets to cancel, right? 6 divided by 6, it just leaves 1 in. 7 times 6 is 42. 9 times 6 is 54. There's not any parentheses. There's no math I can do. All my letters, my variables, are already on the same side. So just undo anything being added or subtracted to the variable. Same thing to both sides. So n equals 54 minus 42. 12. Okay. Fractions. Oh, get rid of the fractions. Make sure you have an equal sign. I need a common denominator. Oh, that's a 4. So I'm going to multiply everything all the way across. Everything by 4. Now, 3 times 4 is 12x. Right here, I have 4 divided by 2, so that's going to cancel. And really, that's just a 2. So 1 times 2 is 2. Here, 4 divided by 4 completely cancels, and all you're left with is the 3. There's no parentheses. There's no math I can do on either side. My variable's on the same side, so undo what's being added or subtracted. So 12x equals 1, and then undo what's being multiplied. So 1x equals 1/12. All right, let's practice that a little bit more. Oh, fraction. Let's get rid of it because we have an equal sign. Multiply by 3. Everything by 3 all the way across. Okay, 4 times 3 is 12. But right here, those 3's get to cancel, so all that's left is that 2 times n. Negative 10 times 3, 2 times 3. Okay, here's some math I can do. There's no parentheses, but I've got some math I can do on this side, so I need to do that. Signs are different, means minus. 30 minus 6 is 24. Keep the sign in front of the biggest one. All my n's are on the same side, so undo whatever's being added to the n. Now be careful, this is a plus 12, a positive 12. Oh, this is a positive 2. I need to know what this number is. Positive 12. So I'm going to take away 12. Same thing to both sides. So 0 plus 2n. Signs are the same, means add. Keep the sign in front of the biggest one. And then undo whatever's being multiplied to your variable. So divide by 2 so that you have 1n equals negative 18. Ooh, fractions. I need a common denominator. Common denominator is 15. So multiply everything times 15. Everything times 15. All the way across. Don't forget anything, fraction or no fraction. Okay, now 15 divided by 3 makes that really 5. So this is y times 5. 15 divided by 5 makes that really 3. So this is 2 times 3. 15 divided by 5 again is 3. Y times 3. 15 divided by 5 is 3. 2 times 3. Okay, I don't have parentheses. Put all my variables on the same side. So I want these y's off of here. No y's over here. But I have to do the same thing to both sides. 5y minus 3y. 2y plus 6 equals 0 minus 6. Now that my y's are all on the same side, undo whatever's being added or subtracted. So I need a minus 6 both sides. So I have 2y equals, signs are the same, means add. Keep the sign of the biggest. Undo anything being multiplied. So that you have 1y equals negative 6. Okay, I need a common denominator. It's 12. So let's multiply by 12. 12 divided by 6 is 2. So that's really a 2. 2 times x. 12 divided by 4 is 3. So that's really a 3. 18 times 3, if you have to go over to the side, that's fine. It's 54. Okay. I don't have any parentheses. All my x's are already on the same side. There's no math I can do. So there's nothing added or subtracted to the x. So undo what's being multiplied by the x. To get 1x equals 54 divided by 2 is 27. Okay. Whoops. Now, so far, each linear equation we've solved has had a single solution, but some equations are not true for any real number, and some are true for every real number. Think about this. Just because I write 3 plus 1 equals 5, I can write an equation, but it's not true, right? And 3 plus 1 equals 2 plus 2. Oh yeah, that's always true. No matter what number I added to both sides, as long as it's the same, because they're both the same on both sides. So, sometimes we're going to have no answer, and sometimes we're going to have all answers. When we're going through the steps to solve an equation, our clue that we either have a no solution or infinite solutions is if the variable gets eliminated. Do not stop until your variable is the one that gets eliminated. And then you'll be left with something like this, just numbers and no letters. If it's not true, you're going to say you have no solution. If it is true, like 7 equals 7, then you're going to say it's true for every real number. Okay, here's our no solution symbol, right? And there's several options to indicate the equation has all real numbers as solutions. One of them is just to use this symbol. So that's what I'm going to use on here. This is no solution. And this is all real numbers, because that's our sign for all real numbers. I think on your MyLabs Plus, it gives you options. It'll say the answer is, and it'll be a multiple choice. The answer is blank, okay, and then it'll say there is no solution, okay, and then it'll say all real numbers. And so you'll pick one of these if there's not an answer. All right. So it's the exact same steps. We don't even know the difference until the very end. So the exact same steps to solve a linear equation. Get rid of the parentheses first if there's not fractions. So we have 5x minus 5 equals 3x minus 7 plus 2x plus 2. Okay, do any math you can do on each side. Nothing I can do over here. But here, whoops. But here, I can combine these constants and these variable terms. So this side stays the same. 3x plus 2x is 5x. Negative 7 plus 2, signs are different, means minus. Okay, keep the sign in front of the big one. Then move all your variables to the same side when there's nothing left to do. Move all your variables and notice what happens. Not just because you get a 0. Some people mistakenly think, oh, when you move the numbers and they both go. No, it's when the variables go away. And you wind up with an equation with no variables. Now, if it's exactly the same, your answer is, oh, all real numbers. All real numbers. Same thing over here. Get rid of your parentheses. Now be careful, this is a 1. If there's not a number there, that's -1 times x and -1 times 3. Do any math you can do. So on this side I can combine my x's. Signs are different, means minus. Keep the sign in front of the biggest. 5 minus 3 is 2. Put all your variables on the same side, so let's add x to both sides. Oh, if your variables disappear, you make a choice. And because this is not true, then my answer is there is no solution. Okay. Let me know if you need anything.